right, so we're going to look a little bit at GCF, specifically for algebraic expressions where you have variables in them. GCF, again, stands for the greatest common factor. There's videos I'll link in the description about these two methods, but we're going to look at how we can use those if we end up having variables in them, such as x's or y's. So let's say, for example, we had 20x and 30x, and you had to find the greatest common factor, or the GCF. So if we were using the prime factorization model, what we're going to do is we're going to start by splitting up the number and the variable. Now, usually when we use the prime factorization model, we circle when we get to a prime number. If we have variables, we just circle when we get to the variable kind of being by itself. And then I'm going to split up the number like I would do normally. Right, so every time I get a prime, I will circle it. And then we're going to do the same thing we usually do, where we just list out the factors. So 20x is equal to 2 times 2 times 5 times x. 30x is going to be equal to 2 times 3 times 5 times x. And I'll do the same thing I usually do, where I'm looking for what is a common factor in both lists. So we see a 2, we see a 5, and we also see 1x. So then when we're listing out our greatest common factor, again, this is basically the same method. There just happens to be a variable here. So we'll do 2 times 5 times x. 2 times 5 is 10. 10 times x equals 10x. So 10x is your GCF. Okay, again, remember when the number is touching a variable, like the 10 touching the x, that means multiplication. If we're doing the upside down birthday cake method with this, we would do 20x and 30x. We would draw our layer. I like to take out the variables first, so I'm going to put the x right here. So I'm dividing by x. Now, just to remind us, if you have a number, right, if I had 20 times 2 divided by 2, that's going to equal 20. If I had 20 times 3, which is 60 divided by 3, that's also going to equal 20. So if I have 20 times x divided by x, that's going to equal 20 as well. So if I'm dividing x, putting that x on the outside, I'm dividing that from 20x, I'll just end up with 20. If I divide 30x by x, I'll end up with 30. Now I'm going to do the normal process of just taking out numbers. I'm doing small primes. Can do F5 right here. That'll give me 2 and 3. And then I loop again those numbers on the left-hand side, multiply those together, and that'll give me my GCF. So 2 times 5 times x equals 10x. That's your GCF, your greatest common factor. Okay, so that's if there's just one variable. However, often you'll have two variables. So let's do one more example, something maybe more likely what you would have. 30x squared y and 60xy squared. Okay, so we'll do this with both methods. I'm going to do like I did before. I'm going to split up the number and the variables. Then I would do the number like usual. For the variables, I'm going to be splitting it up. X squared y means x squared times y. So I'm going to do x squared times y. Now that y is by itself, so I can circle it. X squared means x times x, so I'm going to just put 1x here and 1x here. I'm going to do the same thing for 60xy squared. Let's see, we've got here. Again, we're just doing the same normal process we do when we're doing the prime factorization. For my xy squared, I'll split that into x and y squared. Again, y squared equals y times y. So I'll list those both out. So now I cannot circle anything else. I'm done with all of those. So I'm going to list out all my factors. 30x squared y equals 2 times 3 times 5 times x times y. 60xy squared is going to equal 2 times 3 times 5 times x times y times y. Then I'm going to look for what they have in common. So I see they both have 1, 2, they both have 1, 3, they both have 1, 5, they both have at least one x and they both have at least one y. So I can see there that I've got 1, 2, 3, 4, 5 loops. So I'm going to multiply all those 5 things together. 2 times 3 times 5 times x times y. 2 times 3 is 6. 6 times 5 is 30. So that gives us 30xy is our GCF using this method. So again, very similar to the other method. You just add the x's and the y's onto it. All right, so if I'm going to do the birthday cake method, I'm just going to write my same numbers. I'm going to factor out the variables. So I'm going to start by factoring out an x. Now, if you have x squared and I divide by an x, that means I'm going to have one less x there. So that's going to leave us with 30xy. On the right-hand side, we've got 60xy squared. So if I divide by x, that's going to get rid of the x, and I'm just left with 60y squared. I'm going to draw my line. I'm going to factor out a y. Again, I'm trying to get all the variables that I can that I see in both of these expressions. So that would leave us with 30x. And on the right-hand side, 60y squared. If I get rid of one of those y's, I'm going to be left with 60y. Now, there's no more variables that they have in common, so I'm going to have to just start taking out numbers. So I'll take out 2, which gives me 15x and 30y. I'll take out a 3, which leaves us with 5x and 10y. And then we'll take out a 5, which leaves us with x and 2y. Again, we just loop the numbers on the left-hand side. We're going to multiply those together. Should look familiar to what we had when we did it the other method of prime factorization. That equals 30xy for your GCF. So, right, so we pretty much just do the same thing we did with normal GCF. We just put some variables in there and we make sure we factor those out as well.